Hello students, let's start numericals on steady state pattern. Now, before getting into this module, let us quickly revise all those formulas which are required to solve numericals on this module. The very first formula, guys, it would be for bandwidth. What is bandwidth equals to? Bandwidth is nothing but equals to lambda d by d. Exactly. Now, second, what if the bright band is separated by central bright band? What would be the distance between them given by? So I would say that nth bright band and CBB, the distance xn would be nothing but equals to n lambda d by d. The similar case would be for dark band. What would be the distance between any mth dark band and CBB? So the answer would be given by the formula that xm dash is nothing but equals to 2m minus 1 lambda d by 2d. So guys, where n and m are integers, n starts from 0 and m starts from 1. That is the basic difference between these two formulas. Let us take the first numerical here. By passing light of wavelength 5000 angstrom unit through two pinholes 0.5 mm apart, an interference pattern is formed on a screen kept parallel to the plane of the pinholes and exactly at 100 cm away from them. Then you need to find out the distance along the screen between third and the seventh dark bands which are on the same side. So given is nothing but lambda, that is wavelength is 5000 angstrom unit. We need to write it in terms of meter, so we know that relation is nothing but 1 angstrom unit is nothing but equals to 10 raised to minus 10 meter. So we get 5 into 10 raised to minus 7 meter here. This is what is lambda. And two pinholes, that is 0.5 mm apart. So small d is nothing but 0.5 mm, and converting mm into meters, it looks like 0.5 into 10 raised to minus 3 meters. For further simplification, I can also write it as 5 into 10 raised to minus 4 meter. And what else is given? A very important screen's distance which is kept parallel to the pinholes, that is capital D, is exactly equal to 100 centimeter, and we know that 100 centimeter is 1 meter. So this is what is given in this question, students. Now we need to find out distance between 7th dark band and 3rd dark band. So if the pattern is given, we would get visualization of it. So we need to find out differences, and here is that pattern, that 7th dark band and 3rd dark band. We need to find out distance between them, and how it can be achieved. It can be achieved by finding out x7 dash minus x3 dash, right? So let us find out x7 dash and x3 dash separately. But in order to find it out, we need to use this formula that xm is nothing but 2m minus 1 lambda d by 2d. M is the number of dark band. So whichever bright band's distance you need to find out, just substitute its value instead of m. So let us start the numerical. We need to find out with the very first 7th dark band. So for 7th dark band, x7 dash would be nothing but, instead of m, substitute 7. So it would be 2 into 7 minus 1 lambda d by 2d. And for 3rd dark band, it would be nothing but x3 dash equals to 2 into 3 minus 1 lambda d by 2d. And we need to subtract this both so that we get the exact difference. So x7 dash minus x3 dash goes like 13 lambda d by 2d minus 5 lambda d by 2d, right? So on subtracting this, we are going to get it as 8 lambda d by 2d. So students, this is what is the difference is. We have lambda's value, we have small d's value, and we have capital D's value. Let us substitute everything one by one. There's a simple mathematical operation that 8 is nothing but 2 4s. So after that we are substituting values of lambda here, and after this we would be substituting values of small d and capital D exactly at their positions. And on simplifying, you are going to get x7 dash minus x3 dash equals to 0.4 centimeter. Okay, second numerical. The second numerical is, in Fresnel's biprism experiment, the distance between two images of the source is 0.6 mm, and the distance between source and the screen is 0.5 meter. Then it is given that overall separation between 20 fringes on the screen is 3 centimeter. Calculate the wavelength of light used. If I am going to write down the given data here, then it would be nothing but, first, small d is 0.6, that is can be written in further simplified as 6 into 10 raised to minus 4 meter. And the second data, that distance between source and the screen, that is capital D equals to 1.5 meters, right? And the very important data given for this question is distance of 20 fringes. A single fringe is x, right? 20 fringes means it is going to be 20x. So 20x would be equal to 3 centimeter, that is 3 into 10 raised to minus 2 meter upon 20 it would be now. Right, students? So these are the following data. Let us take this thing and let us try to find out what is exactly their separation. So we say that lambda is to be found out because we need to calculate the wavelength, and the separations formula is x is equal to lambda d by t, and just as in we are going to find out lambda for this numerical, lambda would be equal to x d by capital D, right? So students, this is what is given in the formula. We have all these three values, then why not substitute and get the answer? It's a direct substitution kind of numerical. I'm going to substitute value of x here, then value of small d, then value of capital D, and I would be getting direct answer on simplification as lambda is nothing but equals to directly 3 ones are 3 tens are, and the whole 6 into 10 raised to minus 6 the whole upon 10 would be written as 6 into 10 raised to minus 7 meter. This can be also expressed in terms of angstrom unit, students. And need to express in terms of angstrom unit, you need to convert 10 raised to minus 7 as 10 raised to minus 10 as given on the screen, and this 10 raised to minus 10 meter can be written as angstrom unit. So these were the two numericals from this particular module. Thank you.